Good morning, everyone, and welcome to session 4 of our BDTI Essentials course. It's great to have you here. Today we'll be talking about some analytics, data analytics, visualization, and reporting techniques. So, next slide, please. Just some housekeeping if you've not been here before. The chat and Q&A widgets are on the bottom right of your screen. If you have questions related to the content, please post them in the dedicated Q&A section, which we'll get to at the end. The session is being recorded, so you can come back and revisit anything that you might have missed during the session, and it will be available shortly afterwards. Please do participate in the chat during the session, ask your questions, and let's stay respectful. Yes, if you don't see the Q&A, this is how you can enable it, the three dots at the bottom right of your screen. Today, we'll have a short recap on session 3. We'll go through into the main data analytics content of the webinar. We'll have a Q&A, and then we'll wrap up and give a quick introduction to session 5. So I'll pass the floor over to Maria Claudia to give a brief introduction.
Thank you, Kim. Thanks, everybody. Also, welcome back. This is Maria Claudia, and together we are here to go further with our use case today, with our data analytics session, with this big data test infrastructure essential course. You know, we are almost at the end of the training, where our main goal was about spreading the word about the big data test infrastructure, but also to help you in create a very interesting use case. You know, this is what we are currently offering. It's basically a data science playground, completely based on open source tools, where you, public administration, can experiment with data for free. You know, if you go to the next slide, we already tried in the previous session to convince you about to apply for the project, and we are also trying to foster synergies between academia, public sector, private sector, and try to really move forward with the data-driven public sector. Please feel free to share this opportunity in your network. And we really hope that now you are feeling more excited in applying for it. The process is very light, it's very easy, and you can check our website for all the information. Then if we move to the next slide, just a quick recap about our tools. You probably are now familiar with some of them. And in the first 3 sessions, we already use NIME, we already use PostgreSQL. We try also to use Jupyter, R. And today we are going to add a new tool in our picture, that is Apache Superset. So basically we are moving little by little to the end of our data journey. Then just to have another quick recap, if we move to the next slide, don't forget about our use case. We are working with Zoe and her team. They are working in an educational department in a highly polluted EU region, and their focus, their goal is really to identify possible synergies, basically universities that are working in green projects. The idea is to try to understand where they can discover new collaboration, and also which partnership they can try to foster to address pollution issues together. Then if we move to the next slide, you can have a very quick and nice recap about our training. So in the first session, we start looking for the data and also for the right information, and we start using 3 different tools. Then in the second session, we try to clean all this data and this information, and we start transforming them in let's say, a more nicer and also more reusable format. Then we went through session number 3, where we blend and store our data to be reusable and also easily accessible. And finally, today, we are really moving forward with the real data analytics part that is really exciting. And in this session, we are going to try to find correlation, insights, and patterns to concretely support Zoe's question. Please keeping in mind that what we are doing in this training is highly reusable. It doesn't matter if we are discussing about Zoe or other use cases. the session and also the content of this session is can be adapted for different contexts and also for different domains. Don't forget, all the material is public available. You can find the recordings, also the slides we used in the previous sessions, and you can try to do everything by yourself, also on your notebook. Let's now review the homework together, and then let's go to this really interesting session. Thanks, colleague, and thanks also, Julian, for being here today with us. The floor is yours.
Thank you very much, Maria Claudia. As mentioned, I'm joined today by Julian in the studio. Welcome, Julian. Trinidad is out for the week. And Julian, let's jump into it directly. Let's have a quick recap of what we did in session 3, where we focused on data blending and storage. And just to refresh everyone's minds, the basic concepts we dealt with there on the blending side, that's when you combine different data sets. First of all is the concept of stacking, and that has to do with if you have two data sets, like we have also in our use case, that has the similar columns, that means they have a similar structure. And basically, if you look at my hands here, you stack the two data sets on top of each other, and the basic result is that you add rows, more information to your data set. The second concept that we dealt with last week is joining, where you actually, if you look at my hands, you're not stacking on top of each other, but you're actually joining tables in a fashion like this, horizontally, where essentially you're adding columns to your table, which means you enrich the information that you have. And then on the other side of the spectrum, if you look at the diagram right at the bottom, we did our access, we cleaned and transformed the data. Now we started to blend them. And at the end, we had the table that we wanted to use for analytics today. So we got everything prepared for today. But then it might be useful to either send this to a colleague via CSV files. So you want to export it to a certain file format, or if you want to start using big data and start to scale, or just use best practice to have a central place to store your data, then databases start to play a role. Now, Julian, maybe you can also refresh to us how these concepts, especially the blending of the data, actually refer back to our use case, which is super important for today, because now the contextual layer really starts to play a role again in terms of what to analyze, what insights to get. So Julian, take it away.
Exactly. Thank you, Skalk. So basically, we are working with the Horizon data. Horizon is an initiative by the European Commission to fund green projects, for example. And this Horizon funding usually happens in different time periods. So the last period was from 2014 until 2020. And the next period started in 2021 and goes until 2027. So now we have data already from the previous period, but also already from the second period. And we now want to combine the data for period 1 and period 2. And the different data sets that we have is a data set about the organizations that are participating in the projects. And additionally, another data set that is more about the project information itself. But for both of these types of data sets, we basically have two different periods. So at first, we would like to combine the organizational data. So we have the data from period 1 and period 2, and we want to stack those organizational data on top of each other. We do the same with the project data. We also stack the project data on top of each other. And in the next step, we want to merge the organizational data and the project data together into one table, so that we basically have the project information and the organization information in just one single row for that particular project. Additionally, there are also some additional data sets like the EuroCVOC, which provides us with broader information about some projects, so in what kind of domain they fall, basically.
Exactly. And again, it's super important. What we did in the previous session was to combine all the data, and that's going to make it a lot easier today to actually get the insights from that. But let's jump now back to the actual exercise that the people could do. and you can show us live how this would look like.
Exactly. So a similar step as in the previous sessions, we first start by logging in into the BDTI portal. This is where we have all our services available. So for example, we have our KNIME service, which we will use now for having a look at the previous exercise. So we can go to My Services and then open the KNIME service from here. So as usual, we need to also get the secret for this service from our My Data section. We can copy it from here, and then we go back to our tab where the KNIME service is running and provide the password here. So now we're logged in into our virtual machine, and just to recap what we've mentioned before, we started out with our data sets. So what we see here on the left-hand side is that we have the organizations data for the period from 2014 until 2020. We have the organizations data for the period from 2021. And we do have the same for the projects as well here. So in the second session, we then transformed the data to bring it into similar shape. And in the third session, or in the third exercise, we are now trying to combine the data from the different data sets. So at first, we're taking the organization data, using a concatenate node to stack the data on top of each other. Because when we have a look at our incoming data sets, we see, when we have a look at the table, that there are 7 columns in the first data set, and also 7 columns in the second data set, and all those columns are matching. So in the concatenate node, we can now stack those data sets on top of each other. When we have a look at the configuration of the concatenate node, we see that this node doesn't really have a lot of options that you can choose from. There is one option that can be important in some cases. For example, if you have data sets that don't have matching columns for all the columns, you could define how you want to handle these kind of columns. So do you want to remove columns that are not in both tables, or do you want to union the tables so that if there is one column more in one of the data sets, to keep it and produce missing values for the rows where we didn't have that column. So basically, we did this concatenation or the stacking now for the organizational data, but also for the project data. And in the next step, we want to enhance our organization data set by joining the project information to it. Because when we have a look at our concatenated or stacked table now, we see that we have all kinds of information for the organization. So we have the organization name, we have the country where it's coming from, and we also have the project ID. So we know in what kind of project the university, for example, was participating in, but we don't really have a lot of information about the project. It's just the ID that we have as a reference in our data set. So when we have a look at the project data now, we see we also have these IDs in that data set, but we have additional information about the project. So when did it start? When did it end? What was the total cost of the project? And what were the objectives of these kind of projects? And we now want to have all that information within the same table, and that's why we are using the join functionality in KNIME. So we can go to the joiner node here, and when we have a look at the configuration of the joiner node, by going to the joiner settings tab at the top left, we see that we can define a matching criteria. So you can also have multiple matching criteria. You can add a new criteria by clicking this plus button here. But in our case, we've already prepared this, and we've selected the project ID column from the organization data and the IDs column from the project data set. And now this is the matching criteria, and the columns of the project data is now appended to the organization data. So in case you don't want to carry along all the columns, you could also go to the column selection tab and decide which of those columns should actually be in the resulting table. So this is about the merging operations. We had the stacking, we had the joining, and in the next step, we wanted to export and store the data somewhere. So in that case, we had a look at storing the data as a flat file. In this case, we were using a CSV to store it in a CSV. For that, in KNIME, we can use the so-called CSV writer. The CSV writer allows you to write a CSV to any kind of location on your machine, or in this case, on the virtual machine. And then you can share it with your colleagues, for example. However, especially important for the BDTI framework is that you're working with a lot of different tools within that BDTI framework for various different use cases, and you might want to have some kind of a central repository for your data. And in that case, it makes sense to use a database. In our case, we were using a Postgres database, and in KNIME, you can easily connect to it by using a PostgreSQL connector, where you then in the configuration define the connection information, so the host name, port, username, password, everything that you can get from the BDTI portal where you started up the database. And then in the next step, you would write it into the database using the DB writer node. And the only thing that you need to provide here is basically the name of the database table that you want to produce. In our case, we named it session 3, and then you can also define which of the columns you want to write into the database. In our case, we chose all of them to really have everything in our database. So just to do a little sanity check on whether the writing to the database worked fine, we can go again to our BDTI portal and open up the PG admin service in our My Services section. So I can open this one up. And in my case, I'm already logged in. Might be that you are prompted to provide the credentials as well. Then you can go to the My Data section again, get the password from there and use it to log in. And on the left-hand side, you see this Object Explorer, and there you see also the server with the databases. And inside of our Postgres database, we then go to the public schema and to the table section. And here we see we have our session 3 table. We can right-click it and go to the query tool, for example. And in the query tool, we can provide some kind of query. So I'll just use a simple select statement. So what this statement does is that it selects every value, every column from our database table called session 3. And then we can run it. And now this query is being executed, and we will see in our data output, let me run it again. We see in our data output basically our, no, it should work. 1 second. Let me run it again. Okay, worked before, but usually we would see our data table in here, and just as a sanity check. However, we can also have a quick look at the columns here and see if all the columns are available, which also doesn't work. Maybe I would need to re-log in. But yeah, I know the data is there because I will use it in the next part.
And if you want to just review the sanity check, I think there's just a connection problem there at the moment to the database. We did show that in the last video. And again, the sanity check basically check the amount of columns, amount of rows. But if you don't know how to do SQL, just a reminder, SQL queries, and you don't have time to learn that, that's okay. It's not a necessity. You can stick to the low-code, no-code tool where you access your database and you can get your data from there. So let me grab back the screen from Julian, and then we continue with today's session. And just a quick summary, what we just recap So, because we also didn't show all the parts of the exercise, you can go download the solution from the GitHub repository. And there, just a reminder, we had 5 different data sets, but it was divided into 8 different files because for organizations, projects, US SciFOC, we had 2 data files because we had different periods. And we also have information on the CO2 emissions for countries, and the CO2 country names, we had to do some standardization. That's all to say that we, in the data blending part, put all these data, blended all these data files and sources together, and we showed that you can upload it to a database. We can later on access it again. Okay, Julian, that being said, let us now go over to session 4, which Maria Claudia already mentioned. A very exciting session because now we've been doing all this data prep, which is super important to get to this point, because if you don't have quality data, you don't get to a quality analytics or insights. But now we are actually at the point where you can do that. We're going to jump into this. And if everyone follows along today's session, I would also recommend rewatching recordings, going through the exercises, etc. But if they do this, what should they be able to do after today's session?
Exactly. So similar to what we already learned in the previous sessions, again, we will learn, or we will again sign into the BDTI framework. We will make use of the tools that we've already been using, such as KNIME, pgadmin, and Postgres. And now there's an additional tool that we will be using, which is Apache Superset, which we use for visualizations. And when we have a look at the previous session, we've written the data to the database, and now we are trying to get that data back from the database, either by using KNIME or using Apache Superset. And then we are trying to make more sense of our data by applying basic aggregation methods, and then later on also create visualizations, because after the aggregations, we still have a table that might not always be nice to look at. So we create some visualizations and a basic report, which then can be shared with our colleagues.
Exactly. And a quick reminder, if you don't have access to the BDTI framework, please do and go and apply for that. If you can't apply, remember all the tools provided here are open source and you can go download them directly and recreate it at home as well. So speaking of getting insights from the data that we prepared now, transformed, cleaned, put into one data set, now we're set to get the insights. How can you do this? So we're going to look today at 3 main ways of doing this. First of all is aggregation. And this could be simple or could be a bit more complicated. We'll get to that in a second. But in essence, you want to summarize your data. Now, if you do add a more complex layer to your aggregation, you can do some pivoting as well, where you break it down to more detailed layout of the data. And if the table is not enough, that is where visualizations come in. But just keep in mind, this is the 3 things that we will be looking at today. Now, very important, Julian, because where we are now with the analytics part has to do with the contextual layer and the data layer really coming together. So if people recall, we already had Maria Claudia mentioning Zoe's use case again, but and she had a main objective looking for the partnerships, but we also broke it down into sub objectives here. Could you maybe just relate it a little bit to the insights we're looking for to get today, and maybe a little bit of how the methods that we are looking to get these insights?
Yes. So we already know from what Maria Claudia said that Zoe is looking for potential partnerships to work on a green project, because she's from a highly polluted country within the European Union, and they're trying to do something against it. So we took this objective, this main objective, and broke it down into smaller pieces. And this is what we see on this slide. We're basically going to create 4 different visualizations. And the first objective that is interesting for us is that we try to identify the countries with the most university involvement in green projects, just to see in which countries we have involvement. We can then visualize that with a bar chart, for example. We will see that later. And the next step, we want to identify the most active EU-based universities that are involved in these kind of green projects as well. One other thing that might be interesting is also adding the dimension of time to a visualization so that we can identify trends. And in our case, we want to identify the trends in started projects per country per year so that we see, okay, for example, when did Belgium start a lot of projects in which year, and is it still the same, or are they not doing a lot of new projects right now? So this is something that we can then visualize with a line plot. And one thing that also can be very relevant and also helps us to understand the data much better is also exploring relations between different columns in our data set. So in our case, the objective would be that we want to find out the relation between the number of projects of the universities, the total cost of these projects where these universities were involved in, and also the country's CO2 emissions, so the country of the university. And then having all of that in one single chart to identify whether there is a relation between the number of projects of a university and the CO2 emissions of the country where that university is coming from.
Exactly. So again, this is all the insights we want to try and get now from the data, which can guide Zoe and her team to potentially identify a partner university or universities. To do that, let's first of all jump into the topic of data aggregation, which is one of the first things that you can do to get insights from your data. What is it? We already mentioned it, but it's worth saying again. It's really all about getting a summarized and condensed version of your data. Now, to do this, you normally choose a topic or a category, a column, which you want to group, which is the main thing that you want information for instance, universities or countries. I want to know more about them. And then you can do multiple things. You can aggregate multiple topics to add information for them. And there's also multiple methods you can use for aggregation. You can sum the data, you can count them, you can get the average. So this is the basics of what data aggregation is. Let me actually jump into an example to make this clear. Again, data aggregation, the key concept to understand, if you haven't heard of this before, is all about grouping, right? So let's look at our table here at the left. It has 3 columns and a bunch of rows, and you can see the product ID, the category, and the ordered items. And the column, the table here to our right, you can see is a condensed version. That's the result of the aggregation. Now, in this instance, we are interested, and this is our grouping column, interested to find out more information about the categories, clothing, home, the items that were bought for them. So this is the category we were interested in. And what do we want to know about them? How many items per category label was actually bought, right? So you can see in the resulting table, all the clothing rows have been grouped into one row, and for all those rows, the ordered items have been summed. And it's the same for home and electronics. So that's a basic idea of aggregation. Now, let me show you again, just to make this concept very clear. If you have a table with a lot of columns, the first step should be, sorry, I clicked too quickly there. The first step should be to choose the grouping column. So I want to information about this column. And what do I want to know? That is your aggregation column. That is the one that I want to count or get the average for, and so on. So this is basic aggregation. Imagine now you have another column here, maybe the price per item. You could do multiple aggregations and find out, excuse me, for instance, for clothing, there were 8 items ordered plus the total cost of these items. So you can have multiple aggregations for your grouping column. So that's kind of taking it to one step further. Now, to give you a concrete example from our data set, here you can see I have a snippet from the data table that we've combined in the last session. And here my grouping column is countries. I want to find out more about countries. What do I want to find out? How many projects were involved? So I'm going to choose a column just to count. And you can see a resulting table has only 2 columns, where the first one had 17 and only about 30 rows versus 21,000 rows. Again, the basic concept is grouping and choosing your aggregation. Now, within the BDTI framework, we have, of course, various tools that you can do this with. Here's a reminder of them, the ones that we looked at so far. We are only now demo the one in Lime, which is the low-code, no-code version. If you are proficient in scripting, you can, of course, just use one of the scripting tools. But Julian, I'm going to ask you to take over the screen again and just demo for us how aggregation, simple and maybe a bit more complex aggregation, would look like on the data set we had. Over to you.
Thank you, Skalk. Before we actually dive into the aggregation part, let's first have a look at how we could actually get the data back from our database. It might not be necessary for our KNIME workflow, because we have our KNIME workflow where we've prepared the data. We might use the database to store our data to then make it accessible also for other tools. But in our case, we could just continue with what we've already built without using the DB, the database functionality. But still, I want to show you real quick how you could connect to the database and get the data from the database table that we've written in the last session. So you have the PostgreSQL connector to connect to your database, and as a next step, you would use the DB table selector. So the DB table selector, when you open up the configuration, you basically see the schema and the table that you want to select. So the thing that I've been doing in the PG admin console, where I provided the SQL statement, this is what this node does as a low-code variant of it. So when we select the table, we see the output port is a little bit different. This basically just propagates the SQL statement that is created internally to the so-called DB reader node. The DB reader node then executes that SQL statement and pulls the data from the database so that we have it, so that we can access it again in our workflow. However, in our case, we can also simply continue with working with the workflow that we have built. So we know we had our joiner here where we have combined all of our data sets. And I've also added one little step here as well to make the final visualization a little bit more readable and appealing. And when we remind ourselves again what we are trying to achieve, we know that we are mostly interested in universities. So we're not interested in organizations from the private sector, for example. So in our data table, when we have a look at it, we see that there is a column which is called activity type. So this activity type column contains various values. So for example, PRC is for the private sector. There's HES, which is for universities or higher educational institutions. We have REC for research organizations and so on. And we want to convert that into something that is more readable for the end user or for the consumer of the visualization later on. So to basically get more readable names, I've simply created a lookup table manually. In KNIME, you can do that by using a table creator node. You could also simply create a spreadsheet in the tool of your choice and then read it in with the reader node. In my case, I used the table creator, so we can quickly have a look at the configuration. We see I have created 2 columns and added basically the values that are corresponding to the abbreviations. And then afterwards, I'm joining that to our table again. So in this case, the joiner then has the matching criteria for this activity type column, which is present in our original data set, but also in our lookup table. So now we have that available there as well. In the next step, we actually want to filter for the universities. now we want to have a look at the first aggregation type. It's the grouping basically, and we want to filter the top universities with the most projects within the European Union. At first, we were using a row filter node, and when we have a look at this, the configuration of it, we can see I'm using the organization type column, and then as a pattern, the higher education institutions to really filter for only those universities. In the next step, I can then use the row aggregator node that was visible on the slide that Skalk has shown. And this row aggregator node now allows us to group by one single column and create one single aggregation column as an output as well. So let's have a look at the configuration. And we see we can define a category column. In our case, we want to use the name column because this is where the university names are stored. And then as an aggregation method, we simply want to use a occurrence count because we want to count how often a university occurs in our dataset. When I then hit OK and execute this and open up the table, we see we have now one row per university and the occurrence count next to it. I can also already sort it in here, and we see the technical university in Denmark is the university that has most involvement in these green projects. So this would be the easiest way of doing a simple aggregation with just one aggregation column as an output. However, sometimes you want to do multiple aggregations. So in the next step, we want to create the table that later on will be used for our parallel coordinates plot, where we put multiple of these columns into relation. So for that, again, we are using our university data. And in this case, we are using the group by node. The group by node does the same as the row aggregator, but allows you to do more aggregations in just one single node. So when we have a look at the configuration panel of the group by node, we see we have this groups tab, and this is where we define what kind of group column we have. In our case, it's again the universities. We now want to count the number of projects those universities are part of. This can be done in the manual aggregation tab. And here with the group by node, there's one important thing to know. When you're using the occurrence count method, it will not create a new column. So you just need to pick a random column of those that are listed here on the left-hand side. For example, I take this one. And then in the aggregation method, you can decide what kind of method you want to choose. And in my case, I want to use the count function. So next to the project count, we also want to aggregate the total cost of these projects where the universities are involved. So we have this total costs column in our data set, which relates to only one project, but we now want to sum it for all the projects university is involved in. So I can add this as well and then use the sum functionality. Next to that, I also want to drag along some other columns that we might still be interested in. We don't really want to aggregate anything. We only want to keep the values in our data set, because initially we merged also the CO2 emissions for a country. We joined that to our organization's data set so that we always know how much CO2 emissions were present in that country where that university is coming from. And we just want to drag it along and keep that in our resulting table. So for that, I'm using this cumulative CO2 column, and I simply choose the aggregation method, which is called first. It will just take the very first value for that particular university. I do the same for the country name so that we also still know from which country the university is. And then we can hit OK. We've set up everything. And then in our resulting table, we now see we have our universities. We have again the count. We can sort for it. We see the total cost for all the projects a university is involved in. We see the CO2 emissions for the country where that university is coming from, and also the country itself. And then that's
it. And maybe a quick, just a quick disclaimer on what we mean by the cumulative CO2 emissions. Maybe you can just add a little bit of a disclaimer there. Yeah.
Exactly. So we took that data from a website called Our World in Data, and the cumulative column there, or the cumulative CO2 data, is basically giving us the value for all the emissions that happened since we started tracking the CO2 emissions for countries.
Yeah.
So it gives us a general idea of who is the main contributor to Europe's CO2 emissions. But of course, something like the trends are not really part of that column.
Exactly. Just a disclaimer, take it for what it is. It's just helping us to relate it to the other dimensions in the table. Okay, so we've seen now how to aggregate either with one grouping column and one aggregation column, or with the last example with one grouping column, the universities, and you find out multiple pieces of information for them. That is very powerful to do. You can do it all within the one node there. Now let's go one step further and add another layer of complexity. So we have, and this is now the topic of pivoting, and I'm pretty sure a lot of you who have worked on spreadsheets before might have worked with pivot tables. But just to make sure everyone's the same page, let's add this level of complexity and quickly just discuss what pivoting is. So we have a similar table than we had with the aggregation example. The only difference is now we have another column here about the store type, online or on-site. Now, previously, step one, we said, okay, let's choose our grouping column. So we want to find more about the category of clothes or items here. And we chose the aggregation column and we said, okay, give us a sum or count of that. And the result was 2 columns. But here with the pivoting, you see there's result is actually 3 columns, and the headings here now look different. We actually have a breakdown of the aggregation of the ordered items by store type, online and on-site. And to create a table like this, you need to take one of your columns where your labels are actually in the rows, in this instance, online and on-site, and you want to, as the word says, pivot it from a row to become the heading of a column. And the reason, again, why we want to do this, just to emphasize again, is to get a more detailed breakdown of the aggregation that you want. You just don't want all the clothing. You want to know, was the clothing bought, the items bought in the online or online store. You just want to break that into more detail. Now, again, let's repeat the process. You would have to choose your grouping column. I want to find out more about the clothing or the category of items sold in this instance. I want a detailed information, which I get from my pivoting column for the different store types. And then the third step is choose the aggregation column. Again, breaking it down, step 1, step 2, step 3, just to get the concept in your mind. How would this look like from example in the data set before Julian is going to actually demo that for us again. So last time we said we wanted to have an aggregation about the countries in our example. So you can say our grouping is, again, we want to find out more about countries. We want to know how many projects they have again, so we can count them. But we want to break down the amount of projects in the type of project. Is it for university? Is it for private? So you can see here the result has the breakdown, a more detailed breakdown of the number of projects per country. Okay, again, we have different tools to do it. You can do the pivoting in all of them, but Julian's now going to quickly demo for us with NIME how to do pivoting in terms of our use case.
Exactly. Thank you, Skak. So in this case, we want to create a pivot table based on the projects per country. So we want to see in how many projects a country is involved, and then break it down into the different organizational types, such as universities, private sector, and so on. And to do so, we don't use the table where we already filtered for universities, because then obviously we cannot break it down. So we are using the joiner here, and we use the pivot node in 9. Okay, let me drag it a little bit into the right area here. And then let's have a look at the configuration of the pivot node. So here we are now taking the country as a group column, because that's our category, that's our main category. We can use the country name column here. And as a pivot, we want to have this organization type, which then allows us to break it down into universities, private sector, public bodies, and so on. And again, for the manual aggregation, we can simply pick any of the columns that are available here to use it for the count functionality, the count aggregation method. One thing that it's also worth mentioning here is that you can define how the new column names should be named. And in our case, it's already set to pivot name and aggregation name. So we would end up with something like universities count. But since we know that we are counting, we can also use just the pivot name so that we have properly named the column headers. When I now run this and open up the table, we basically see all of our countries here. We see how many of the projects related to the country are also related to universities, how many are also related to the private sector, to public bodies, to research organizations, and so on. And we can already have a look at it and see, by sorting this, we see, okay, the United Kingdom actually has the most involvement with their universities in the projects that are funded by the Horizon program. Then there's one other example that I would like to provide to you. So now we grouped by the countries and broke down the project types or the organizational types. But now we want to do that again, but we want to group by the years and break down by country how many projects started per country per year. So for this, we can also take the joiner node here because we are interested in the overall projects in this case. And we're using the pivot function again. We can then open up the configuration. We can use the start year column to group by the years. We then take the country name as a pivot column. And for the manual aggregation, we simply use the count aggregation method again. Change the column naming to pivot name, hit OK, and then we can run it. And in our resulting table, we now see the years in order and how many projects per country in these years were started. So for example, here we see Austria, for example, started 4 projects in 2014.
Exactly, and this is again tying back to the contextual level. The grouping column in all these examples is the main one, and that's also going to determine what type of insights you get. So if you want a time dimension, you group by the years, and that's obviously going to translate later on into a nice line plot. But there, the decisions, and there's where the domain experts and the data has to be balanced out. You need to know what you're looking for in order to choose the correct category to group. Okay, let me grab back the screen from you. Thank you, Julian. And let's do a quick summary of the aggregation. What it is basically a summarized version of the data. As we saw, all the tables were smaller, condensed, and give you insights or pieces of information about the grouping column that can be useful for you to later on start to make some decisions. You can aggregate by one or more categories. We saw that as well. And if you need more a breakdown of your aggregation, the pivoting way is really, really useful. Good. Now we are going over to visualization. And remember at the start, Julian, we said to get insights, we're going to look at 3 different ways. We've now touched on the first 2, but sometimes you also need to add some visualizations. And the reason for that is that with visualizations, you can get hidden information, hidden patterns essentially that you cannot see in a table. So that also kind of guides you to ask when to use visualizations. It's not useful sometimes to just use a bar chart, for instance, if you can already gain the same insight from the table. But it is very useful when you, especially we'll see in a moment, when you have a pattern or relations that you want to see between different columns, which is just impossible to see from a table. So that's really the main reason. A visualization should be used to add, and not just because it's, I mean, it is fun, obviously, to visualize stuff, but that's not the main reason to do it, right? Now, Julian, maybe let's just again make this very clear to everyone, linking now the visualization methods and techniques we want to use to our objectives and how this could potentially get us some insights, which is useful for Zoe and her team to start making decisions.
Exactly. So our first objective was to have a look at identifying the countries with the most projects, breaking it down into the different organizational types. And for that, we can use a stacked bar chart. A bar chart in general first is helpful to just see let's say the total counts for the country in our example. So total number of projects for the country. So we have this one bar, but we can then break it down and put it into a stacked bar chart where we have like little fractions of this bar where we then see, okay, how many of these projects are actually related to universities or to research institutions. So that's why this stacked bar chart is quite helpful, because we can also see the distributions in just one single bar. Additionally, for the most active EU-based universities, we just take a simple bar chart, no stacking or grouping involved there, just to see how many projects or in how many projects the universities are involved. And then for the trends, that's what we've seen as the last aggregation step, where we basically took the years and counted the number of projects per country per year. This is something that we can nicely visualize with a line plot, because then we can identify the trends for how many projects were started in which year and in which year, and so on. And last but not least, we have the parallel coordinates plot, which then allows us to see the relations between different columns with different values in our data set.
Exactly. And again, let's have a look at the options available for this within the BDTI framework. Now, there's 3 tools that you can use for visualization. Today, we'll show 2 of them, and we'll start off keeping within the analytics platform. That's where we did our data prep. So it makes sense to build the first visualization there, maybe as a dashboard, and show how you can export it as a report, a static report. But then we'll also show, because it could be that one person in a team does the data prep within an analytics tool like KNIME, and then puts it on a database, and then someone else then who's more proficient in visualizations and likes to use a tool like Apache Superset wants to build a dashboard. So we'll look at both use cases.
Exactly, yeah.
And for that, Julian's going to take over the screen. Again, a reminder while he's just grabbing the screen from me, Apache Superset, like all the other tools within the BDTI framework, is open source, so you can also download it yourself and do it.
Thank you. Okay, so we've seen our workflow now. It's actually not exactly the same workflow. It's the same workflow, but I've added already some other nodes to the workflow. And because sometimes, especially when you're doing visualizations, you might need to do some additional preparations, the transformations, very basic ones, but just to really have the visualizations in the shape that you want to have them. So for example, when we think about a bar chart, it would be nice to have the bars ordered by the counts, so that we have the largest bar on the left-hand side, and then it goes smaller to the right-hand side. So that's why we see some additional nodes here, for example, the sorter node to sort by the project counts, column renamer to provide proper names for our columns as well. And this will then help us to properly visualize our data later on. Before we actually show how you can do the visualizations, let me just show the end results so that you already know where we're going. And this is in this visualization component. We will also see what a component is and how you can create it in a second, but let's just have a look at the output. So I can right-click this and open the view, and then make it also a little bit bigger. And we see now we have all the visualizations available and also available in just one window. So on the left-hand side, we see our stacked bar chart with the organizations per country separated, or the project per country separated by the organization type, the top 10 universities. We have our line plot below that shows the trends for the different countries, for how many projects they have started in the past 10 years. And at the bottom, we also see this parallel coordinates plot, where we then see the relations of our different columns. So we have the CO2 emission of the country where that university is coming from. We have the total project cost for the projects where that university is involved in, and the number of projects for the university as well. And then we can hover over a line, for example, here, and we see the University of Delft was involved in most projects with the most total project cost, although it's from a country that is coming from, it's from the Netherlands, and the Netherlands is not one of the main contributors to the CO2 emissions in Europe. So this is already an insight that we could get from this view. Additionally, next to that, we also have a little table view that allows us to have some interactivity. So when I select something here on the left-hand side, it automatically marks the value in the table so that I can then also dive into maybe some other columns that I haven't visualized in the parallel coordinates plot, but I might still be interested in those.
And just quickly on the contextual layer again, here we saw that, for instance, if you have one dimension and you just want to go and choose the university with the most number of projects or the most funding, that could not necessarily be, that could be a naive way to decide it. And that's why that last plot's really interesting, because now you can see Delft is a university with lots of funding, lots of projects, but not really one that is from a CO2 country with a lot of CO2 emission. And remember, Zoe comes from a country like that. So these are now this type of things that you can start looking in relations with all the charts there to start making some decisions. But before we get to that in more detail, show us how to build this dashboard and the visualizations.
Okay, so for the first one, we want to have the stacked bar chart. So we can basically grab our pivoted table here, drag a connection, and we are interested in using a bar chart node. So within the configuration of the bar chart, we need to decide what is our category dimension. It's the country name in this case. We have our numerical columns that have the counts for the different organizational types. We can also provide a title. We can label the axis properly in here as well. And we want to have the breakdown as a stacked, in a stacked way. And we want to have the bar groups as using the category values. So when I now hit save and execute, we basically already get our visualization here. And one thing that we can do with this bar chart as well is that we can also deselect some parts of it. So when we have a look at this bar chart, first we see Germany is the country with the most involvement in these kind of projects in general. But if we take out all the organizational types, like organizations from the private sector, public bodies, and research institutions, we see that actually the United Kingdom is mostly involved, or is the leader in involvement in these kind of university driven projects. So this would be the the first bar chart. Let's stick to the bar charts for a second, because we also have the top 10 universities in here. For that, we used a row filter before that to filter down to only the top universities. And we can grab this, go to the bar chart again. And in this case, when we do the configuration, we have the name column as our category dimension. We can use the occurrence count option here to then basically have the bars sized based on the occurrence count. We again can add a title, label the axis properly, and then save and execute this. And then we see that the Technical University of Denmark is actually the university with most involvement in the Horizon funded projects. And then as a second, we have the University of Delft that we've also seen in that parallel coordinates plot before. Okay, so now let's have a look at the trends. We want to visualize the the started projects over time for each individual country. So for that, we can use the data from below here, and then use a plot called a line plot. In the line plot, we can then again define what is our horizontal dimension. So in this case, it's basically the year, because we want to see the trend over the years. So we have the start year column here, and we want to visualize it for all these countries. Again, basic adjustments like the title, axis labels, and so on can be defined in here. And then I can save and execute it, and I see the trends. So for example, we see, especially in 2015, we had Germany that started a lot of projects in 2015. There was a little dip in 2022, maybe related to COVID. And then in 2023, everything seems to start picking up again. So now we have also the line plot, which provides us with the trends. And the last visualization that we are trying to do is the visualization for the parallel coordinates plot. So we take the data here, and for that we can search for parallel coordinates plot. And in the parallel coordinates plot, we define what kind of columns we would like to visualize. So in our case, we want to have the country's CO2 emissions, we want to have the total project count, and the total cost for all of these projects. Then I can save it and execute it. And now we see basically this view here. And now we can also hover over the line and see the one with the most projects is the Technical University of Denmark, and the one with the most project cost is the Technical University of Delft. And then we basically see again that Delft is coming from the Netherlands. Netherlands not necessarily the main contributor to CO2, but it still seems to be involved quite a lot and might have a lot of expertise to handle these kind of projects.
Exactly. And again, this is now where the domain expertise come in. Once you start seeing relations like that, for instance, Zoe and her team can make a strategic decision and say, hey, let's go with someone that actually has a lot of experience. So maybe a university that has a lot of projects already under the belt, or maybe one that has a lot of funding already. Maybe they can help initialize the funding process or give us advice to apply for that. Or they can do the opposite, say, let's go for a relationship where everything is in the middle, because it's also important for us to have a university that has experience of working within a country that has high CO2 emissions. So again, the relationship between these, plus for instance, the trends over time, can start to help inform the decisions that Zoe and her team need to make. And it's not as simple as choosing one and say, hey, let's go for the top one. It gets a bit more complicated. And this is where having multiple dimensions can help. So now that you've put the plots there, Julian, how do you put this all together into this one view that you showed us earlier?
Exactly. So basically, I can select all of these visualizations, by holding the Shift button and then selecting those nodes. And then I can right-click the selection and create a so-called component. So now we also have such a gray squared box, which is a component. You can also name it. In my case, I can maybe call it composite view. And now we can also enter that component. So we basically wrap all the functionality into it. I can right-click it, go to component, open component, and then we have all our visualizations inside of that component. And this allows us to use KNIME's additional capabilities, especially the layout editor. So we have this button at and the toolbar at the top, which is called Open Layout Editor. And then we can define the composite view layout. Usually what I do is that I clear this layout to then rearrange everything in the way I like it. So in my case, for example, I might want to have the bar charts both next to each other. And maybe I also want to have the line plot and the parallel coordinates plot next to each other. And then I can hit finish. And here at the top, we see we are currently in that component. We can jump back to our main workflow. And when I now execute it and open the view, I see the visualizations are arranged in a way that I wanted it to have. And one more thing that you can do as well, you might want to have this interactive visualization now also written into a PDF report, for example. So for that, you can also enter the component again, go back to the layout editor at the top. And we enable the reporting. Now we can jump back to our parent workflow, and we will see that at the right-hand side, and for our component, we now have two new inputs and outputs. And those are basically used to define first what kind of report we want to create. So we already have this report template creator node here. Let me just reuse it. I can connect it to our component. And what this report template creator is doing is that we can define the page size. For example, are we using A4 as a page size? What kind of page orientation do we have? For example, using a portrait or landscape orientation, we can define that, pass that information to the component so that then afterwards the report can be generated. And this is what we would do with the so-called report PDF writer. I'll also reuse this one. And in the report PDF writer, we can then simply define the path where we want to write the PDF to.
And then you'll get the PDF and you can send it via email to a colleague or something like this. As we start wrapping up, Julian, let's quickly show the other use case. If the data is pushed to the database and someone wants to use Apache Superset, for instance, to build the dashboard with basically the same visualizations we have now.
Exactly. So for this, we would go to the My Services section again. We have started Apache Superset. We can open it up. And then in Apache Superset, the first thing that you would need to do is you go to the Settings section to Database Connections. Click this plus database button, and this is where you then can set up the connection to the Postgres database. You would also simply provide the information, the connection information and credentials and so on, and then you can connect to the database. So I've already done that. We already have the database ready here. And then in the next step, you can go to the chart section and create a chart. In my case, I've already done that as well, so that we can quickly see how that would look like. In this case, I've now taken all the university projects and broke it down by the actual topics, so that we see, for example, the Delft University is mostly involved in projects related to renewable energy, and that might be something where Zoe is interested in as well. And then in case you have multiple charts, you can also create a dashboard, and where you then have multiple dashboards on the same page.
Perfect. Thank you very much. I'm grabbing back the screen from you here, Julian, just to take us back here. Again, there you see the screenshots of basically the same reports in both tools and how we access that. Let's quickly summarize, just put everything together, what we did today. So again, we recommend to go and rewatch the recordings, do the exercises. And if you've done that, you should be able to now do what exactly, Julian?
Again, use the BDTI framework. We again log into the framework, make use of KNIME, make use of the Postgres database. Now we also make use of Apache Superset. In the previous session, we've created our data set that we use as a ground truth for all the different tools. And now we are making use again of that in KNIME and in Superset. We do apply some basic aggregations for our data to consolidate it a little bit, and then create visualization out of it and create reports that we then can share with our colleagues to get the insights.
Exactly, to start making the decisions. And again, if we look at what's coming up in the next session, which is already next week, so make sure you have it correctly in your calendar. The cadence has changed slightly, but now we've seen that we've done the data prep, which is the first 3 sessions. And really this takes long because you really need to make sure that your data is quality data to get quality insights. Today we looked at the analytics, which we can call basic analytics. And next week, we want to look at advanced analytics. And what this will entail, as you can see in the small screenshot there, is not to only plot the aggregations that we did today on a normal plot like a bar chart or something like that, but actually plot it on a map. And this means you have to work with another data type, geospatial stuff. But it's very, very powerful, especially in the use case of Zoe and stuff, where they want to look at the distribution, for instance, of projects or CO2, but on a map, and then they can get some more insights from that. There's one more thing, Julian, that we are going to do next week. Maybe you can just add to that.
Yeah. So we will also have a look at how we can enhance our data by making use of so-called web services. There are hundreds or thousands or millions of these web services available by all kinds of institutions. One example could be that you have maybe a column in your data set which is having French words or French sentences, and you would like to translate that. Maybe there's a web service for it that helps you translating the column so that you don't have to do that. And we will see next week of how you can make use of these web services in KNIME to then enhance your data set even further with additional information.
Again, and that makes a lot of sense, especially when you work with tools like we have done so far. We can automate a lot of these processes. It's fine to translate once, but if you have to do it for 20,000, 100,000 plus or millions of rows or columns, then it becomes a hassle. So that's why it's useful to know that as well. Okay, with that, I want to remind you to practice, practice, practice. Please go and download all the course materials from the GitHub repository. There you can find the link. We have prepared an exercise for today as well. We can redo most of the things that we did today. You can try it out yourself, do the analytics, see if you can make sense of it, see if you can master it. And with that, I want to give back to Maria Claudia. Don't know if we still have time for a question or two, but at least give the floor back. Thank you very much.
Thank you.
Thank you, colleagues. I think it was really an exciting session. We learned a lot. And also we have a lot of things to process. I see some questions in the Q&A section. Let's go maybe quickly through them. The first one is related to, how can I change the label in the bar chart? So maybe this is for Julian. And the second one is quite close, so let's go in together. Within the configuration of the bar chart, there are labels where you can define the name of the X and Y axis, as well as, this is the explanation. Okay, it's not the question. Thanks a lot. It was already the explanation to the question. Maybe we can just quickly show how to change the label in the real example. If you have the time, it will be easier for the participant. Thank you.
Okay, so if we go back to our KNIME Analytics platform and we go to one of the visualizations. So we go back into that component where we have our visualizations and open that one up. And let's maybe take the very first bar chart here at the top, and we can go to the configuration. And you can already click Save and Execute to just preview the current settings that you have for your visualization. And then here on the right-hand side, you see that there are different sections for labeling your view. So when I go to the bar chart here, for example, to the title here, for example, I can now remove it and provide any kind of name here. So let's say it's the projects per country broke down by project or organization types. And we already see that being reflected on the left-hand side. So we already have the title available here now. We can also add the category access label saying, okay, the categories are the countries, and here for the frequency access label, we can say, okay, it's a project counts. And now we have created our chart. And one nice thing that you can do as well is that you see at the top right here, this little arrow button where you can click and also simply download that visualization as a PNG or a JPEG so that you can maybe put it into your slides or something like that.
Exactly. Then back to Maria Claudia. I don't know if there's another question, if we have time, yeah?
Yes, thanks a lot, guys. So there is a second question, is about Sankey charts. So how Apache Superset supports Sankey charts? I would say, yes, this is supported, even if there are still some open issue. If you check on GitHub, you know, Apache Superset is open source tools and is providing some basic, let's say, basic tool to create this type of charts. Maybe I will address the same question to Naim. If this is possible, maybe we can also have a look about Naim capabilities, but I give the floor to Skalk and Julian.
Sorry, did you get the question?
Yeah, okay, I got the question. So in Superset, for example, you can, when you create a new chart, first you would need to select the data set, and then you can search for the charts. So the good thing about this is that you really have a large library of different visualizations here. So you can easily go through all the different categories. There are charts for correlation, charts that are well suited for showing distributions and so on. Let's see if there's also a Sankey diagram. We can see it here when we search for Sankey. There's also Sankey diagram so that we can also make use of that kind of visualization. In Naim, we have a lot of, let's say, native visualizations. We don't have a lot of, not the library as Superset, because Superset is really powerful for these kind of visualizations. But there is one node in Naim that can also be quite helpful when you are building your visualizations, which is the so-called Apache eCharts node. It's also a library that is being used by Superset as well, because it's also an Apache tool. And this generic Apache eCharts view allows you also to choose from various visualizations. So let me just connect that real quick to be able to open this one up. So we see that we have all kinds of eCharts templates here on the right-hand side, which you then can also select. And this will then also show the code for this particular visualization. So if you're interested in that, you can also tweak your visualization a little bit more by diving into the code and change a few values here and there.
Thanks, Julian.
Well, that's really cool because, you know, it's really when it's about open source that you can see everything behind the scene. Thanks a lot for this nice input. I don't see any more question in the Q&A widget, so I think that's all for today. It's already a lot. Just a final slide about the process. Please look in the website. In our website, we have a dedicated page And as mentioned already at the beginning, the process to apply for this amazing environment is really light and fast. So don't hesitate. The last slide is about our discussion board. In case you have questions while you're going through the exercise, or maybe after reviewing the slide, don't hesitate, post your question there, and then we will provide you support. See you in the last session that is going to happen next Friday. So it's not going to be in 2 weeks as it was usually, but just already next Friday. And as Julian and Skalk were already saying before, the last one is going to be even more exciting because we are going to use OpenAPI to integrate and to also interlink different information from external open data APIs. Thanks again, guys, for your lecture, and also thanks to the participant for the high attention and for your interest. Have a nice weekend and have a nice lunch.
Thank you.
Thank you.
Bye-bye.